Hey guys, today we're going to be talking about finding side links off of intersection points made by chords, secant, and secant lines, okay? So what I'm going to do right now for the video, it's probably going to be a shorter video and that's okay. What I'm going to do is I'm going to give y'all 3 examples and then I'm going to show y'all other multiple examples that you could do on your own. And then afterwards, I'm going to give y'all the formula or ask y'all to derive the formula. And then I'll just go ahead and give y'all the formula at the end, the formulas at the end of the video, okay? Let's go ahead and talk about the 3 different types of intersection points that I mean. I have what you probably remember from the last video, an intersection point that's interior, which is made up of 2 chords, okay? And then I have 2 exterior, one made with 2 secant lines. And then, see that you catch this in the video, another intersection point, this time with 1 tangent and 1 secant, okay? So these are the different types of intersection points we're going to be dealing with. And what we're going to do is be finding the side links of these, okay? So I'll leave some room right here for formulas. And down below, we're going to be doing, finding example problems. So for instance, let's start off with an problem for our first intersection point, which deals with 2 chords. I'm going to go ahead and find an example for you. Okay. Let's say this is 10. This is 15. We'll say this is X. And this is 14. Let me try to draw that a little smaller. Let's say this is 14. There we go. Okay, so that's our example problem, okay? The way we're going to tackle this is not that difficult. It's not that difficult. We're going to see that we're trying to find for X, okay? This is all 1 secant line. I'm sorry about that. Here is 1 full secant line. And what I'll do is I have 10 and X and 14 and 15. So what I'll do is I'm going to multiply that 10 and that X. And we're going to make that equal to that 14 times that 15. And what I'll do now is I'm going to go ahead and grab a calculator, which is right over here. And what I'm going to do is I'm going to do 14 times 15, which is 210. So then I have 10x is equal to 210. Obviously, we're going to isolate the x, so we're going to divide by 10. 210 divided by 10. That's 21. So x is equal to 21. So that's an example of how we would find an intersection point when it's an interior intersection with 2 chords creating the intersection. That's an example of how to tackle this problem. I hope you followed along with your own separate sheet of notes. And keep this in mind because I'm going to ask you to derive the formula. And if you have an idea, go ahead and do that for me. To help you out, I'm going to set variables for these. We'll say this is A, that's B. We'll say this is C, and that's D. So if you already have an idea on what the formula would be, go ahead and write that right here. I'll do that towards the end of the video. Let's go ahead and move on to a different, and as a matter of fact, I'll label this one as well before I move on. And this is a D. There you go. Let's go ahead and move on to the second type of intersection point you'll find, which is made up of two secant lines, okay? So let's find an example for you here. Let's say, might have to draw that slightly bigger. Give me 1 second, guys. So let's say we have that, and a secant line going like that, and a secant line going like that, okay? Sorry about that. And then our intersection points right there. We'll label this 12 and that 15. And we'll label this section x minus 1, and this section x plus 8. All right, so this section right here is 12. This section right here is x plus 8. This section right here is 15. And this section right here is x minus 1, okay? Y'all got that? So, what we're going to end up doing is I'm going to multiply this side length by this entire side length, okay? Again, this is when dealing with an exterior intersection point made up of two secant lines, okay? This is the process with this one. All right. We're going to have 12 times, now it's this entire secant line. So what can that be? What is that more likely to be? It's not just x plus 8, because x plus 8 is this singular line. It is going to be x plus 20. We're going to set that equal to something. Similarly, we're going to do the same process with 15 times x plus 14. Again, this is just an example problem. Afterwards, we're going to go over a formula for you. And now we have an opportunity to solve for x, okay? So what we'll do is I'll multiply this 12 inside both of these, and I'll do the same for this 15. Just like that. So 12 times x is, of course, 12x. 12 times 20, I don't know that off the top of my head. So what I'll do is 12 times 20, and that's 240. Is equal to, now I'll come over here, I'll look at this now. 15 times x is, of course, 15x. 15 times 14, don't know off the top of my head, but that's 210. And really, I should have known from this previous problem, but no problem typing it back in again. Here you have a variety of different options, okay? What I'll do probably is I'll subtract this 12x on both sides, so that I'll have a positive 3x. So then I'll have 240 is equal to 3x plus 210. Now what do you think I'm going to do after this? I'm going to subtract 210, right? So when I subtract 210 on both sides, I have 30 here and a 3x here. And because I'm running out of room, I'll just draw an arrow. The x is equal to 10. And that's how you would tackle that problem for an exterior intersection point when you have two secant lines, okay? Now I'll give you a few moments to, if you think you have an opportunity to derive the formula, go ahead and write that up here. If you can't derive it just yet, that's fine. Give you a few seconds and a few moments to do so right now. And while you do that, I'm going to label the next one. Okay. Again, we're going to go over these in just a moment. So this is our last type of intersection point. This is when dealing with an exterior point, except with a tangent line and a secant line, okay? So let me go ahead and find an example on that. Here you go. So what I'll have here is, again, I'll have a circle with a secant line and a tangent line, okay? And what I'll do is I'll make this side length 12, just this side length. And what the side length that covers inside the circle, I'll go ahead and make that 15. So I'll draw an arrow and do 15. And as far as the tangent line, I'll go ahead and make that x plus 5. Not too bad, right? So again, this is the process of what to do when dealing with an intersection point with these, okay? Again. So we have x plus 5, right? So what I'm going to do is I'm going to square this x plus 5. X plus 5 squared. And I'm going to set that equal to something, right? Any guess on what I'm going to set it equal to? It's definitely going to be 12, right? Because we have a 12 there. Times, is it going to be equal? Am I going to multiply it to 15? I'm actually going to multiply it to 27. And I'm going to multiply it to 27 because I want to multiply this 12 times this entire secant line. And this entire secant line is 12 plus 15, otherwise known as 27. So again, I'm going to bring in my calculator. And I'm going to do 12 times 27. That's going to be 324, right? So I'm going to have, now I'm going to rearrange this x plus 5 this way. It's still x plus 5 squared. I just wrote it out twice. And then I'm going to write 324. Okay, see what I did there? I just rewrote the square into two expressions, and I just multiplied the 12 times 27, okay? Nothing out of the ordinary. Just turn the fan on real quick. Getting a little hot. So that's the process there, okay? Now, I am going to square this expression right here. And the way I do that is I do that through FOIL. And if you don't know what FOIL is, then I'm going to write a quick side note here. So what FOIL means is you're going to multiply the first, the outside, the inside, and the last. Now what that means is whatever term comes in first in the expression. So this would be our first, right? Okay. So I'm going to multiply these first, right? So an x times an x is x squared, correct? Now, I'm gonna go back here, and I'm told to multiply the outside. Well, the outside is the two terms that are the outer edge of the whole expression. So it's this one and this one. This is considered the outside, because they're on the outside end of the expression. They're at the very end. This is the first and this is the very last. So then it's x times 5, which is 5x. Okay, we've done that. Now we're going to do the inside. Now the inside is the inner terms that you're going to find in the expression, which again are these. These are the i's. So again, I'm gonna multiply 5x, or x times 5 again, which is going to be yet another 5x. Now this L stands for last, and it means the last term within each parentheses, which is this one and this one, okay? It may be a little confusing just because we're identifying different terms as different letters, but it just means first we're going to multiply whatever we see first. Next, we're going to multiply whatever's on the outside. Next, we're going to multiply whatever's on the inside, which is these two right here. And then lastly, we're going to multiply whichever's on the last. So this one and this one. And 5 times 5 is 25. This is equal to this. But we needed to square them in order to find the appropriate, in order to single out our x, okay? So I could also rewrite this as, I could combine like terms and just say this is 10x plus 25. $324, okay? Now, what I'm going to do now is I'm actually going to move this whole right side. I'm going to just eliminate all of this 324. Okay. So what I'll have is x squared plus 10x and 25 minus 324, and it's going to be a negative number, minus 299, and that's going to be equal to 0. Okay. Now what we're going to do is we're going to try to put this in a form similar to what we see up here, okay? The manner in which we do that, and because I'm running out of room, I'm going to take this, I'm gonna write the remainder of this just on this section. We have x plus 10, x squared plus 10x minus 299 is equal to 0, okay? Now we have to simplify this in a manner that looks similar to this. And what I mean by that is we're going to have two parentheses that's going to equal 0, okay? We have to think of multiples of 299 that add up to 10, okay? Which is difficult to some extent, but it's a matter, just try guess and check at first initially, right? So I'll give you all a hint. Try multiplying 13 and 23. What do you know? It's 299. And can we rearrange 13 and 23 to have an expression that would equal 10 if you add or subtract them? Of course. So you'll have x plus 23 and x minus 13. Okay, now do you see why we needed to turn this into 0? so that we could properly find our x values in an easier fashion. Now, in order for this expression to equal 0, one of these expressions must equal 0, right? Because if I have a times b is equal to 0, either a or b is equal to 0. If this is true, then this must be true, okay? Similarly, if I have x plus 23 times x minus 13 equals 0, one of these expressions has to be 0. And if one of these expressions has to be 0, then here in this specific situation, x must equal negative 23. Because if x was any other number than negative 23, then I wouldn't get 0 here. Similarly, if x was any number here other than 13, then I wouldn't get 0 here. So x can be negative 23 or x equals 13 in order for this expression to be true. Okay? So which one is our answer? Well, let me ask you this. Can a side length be a negative number? It cannot, so our answer would be x is equal to 13. This one would probably be one of the more difficult ones just because there are more steps. However, there is example problems to go along with this that I'll show at the end of the video so that you can get enough practice on it, okay? Now let's go back to our first example, right? What's the first thing we ended up doing, right? Looking at this one. What's the first thing we ended up doing? Well, we multiplied the numbers, the values, opposite from one another. So 10 is opposite from 6, and 15 is opposite from 14. So we set those equal to one another. So if we were to generalize it, what would we put for this? Well, we want to multiply the opposite values, correct? So I'm going to do just that. I'm going to multiply the opposite values and set them equal to each other. And that is your formula for our first type of intersection point when trying to find side lengths. Be sure to write that down on your own separate notes. Let's look at the second example here. What was the first thing we ended up doing? Well, looking at this right here. What's the first thing we ended up doing? Well, we multiplied 12 by the entire secant line, okay? Similarly, if I look at this A, I want to multiply this A by the entire secant line. So how would I express that? Looking back here, I multiply 12 times the entire secant line, correct? 12 times the entire secant line. I want to multiply this A by the entire secant line. So the way I would write it, the way that I would express it is A times A plus B is equal to, similarly, we did the same thing with the other side. 15 times the entire secant line. Therefore, we'll have C times C plus D. And I know I wrote it kind of funky, but the notes for my third example are kind of in the way. I'll try to draw a line to separate that to make it somewhat easier. But that is our example. Excuse me. That is my formula for my second example. Now we go here and we look at what I did first on this third example, okay? I squared this value, the tangent value. I don't want to call it the tangent value, but the length of my tangent line. I squared that. So let's, rule of thumb, when we're dealing with this example, square the value of the tangent line. So what's our tangent line here? It's A. So we're going to square A. And then we're going to set this equal to, what did we set this equal to here? We set it equal to 12 times 27. Well, 12 is up here, right? So then I'll just write whatever the expression or the value or the variable that is correspondent to that 12 value, which is B, right? Times, now if I multiplied 15 here, then I would just put C. But no, I multiplied it by the whole secant line. So the entire secant line is that of B plus C, okay? So now you have all the formulas for solving the three different types of expressions, okay? Now that we have that settled, I have example problems that I will show you at the end of the video, and you're more than welcome to use these formulas to answer those questions, okay? Hope you've been paying attention. I hope you've been taking these notes along with me. Have a great day.